This first concept check question is asking us to classify the reaction shown and then draw the curved arrows to map the electron flow. To classify the reaction, we look at how many reactants are converted into how many products. Here we have one reactant breaking apart into two products. So this will be an elimination reaction. Then, to map the electron flow, we first identify which bonds are being broken and which are formed. Here the carbon-chlorine bond is broken and no new bonds are formed. The electrons in the bond end up on chlorine, leaving a cation on the carbon. So we draw a double-headed arrow that originates at the bond and ends at the chlorine. This concept check question asks us to identify the nucleophilic and electrophilic sites in each molecule shown. First, let's identify the nucleophilic positions. We'll circle these in red. These are the positions with lone pairs of electrons, or carbon-carbon double bonds. So this will be oxygen and nitrogen atoms. And remember that carbons bound to metals, like magnesium or lithium, are negatively charged carbons that will typically be very nucleophilic. And although a carbonyl has an oxygen, it's not a very good nucleophile. Instead, the carbon of the carbonyl will be very electrophilic. The other electrophiles here will be the positively charged carbons, both the carbocation that has a formal positive charge and the alkyl iodide, where the carbon bound to the iodine has a partial positive charge. This last concept check question asks you to identify the following radical reaction as either an initiation, propagation, or termination reaction, and then to draw the appropriate arrows to show the flow of electrons. Here, because the reaction begins with a radical species reacting with a non-radical to form a new radical, this is a propagation step. Now to map the electron flow, I like to see what bonds are being formed and which are broken. Here this might be harder to see at first, so we can color code our pieces. The radical reactant in green and the neutral molecule in blue. Then it becomes a lot easier to see that in the product, we have a new carbon-carbon bond formed, and it's formed between the two carbons that I've circled in yellow. To draw a curved arrows, we need to remember to use single-headed arrows to indicate the movement of one electron. And then I draw one arrow from the radical to a space between the radical and the other reactant, and a second arrow from the pi bond that's broken to meet with the first arrow. And these two arrows indicate that electrons are coming from these two locations to form a new bond. Then the other electron that was in the pi bond moves to the carbon to become a new radical. So I indicate that with another single-headed arrow that originates at the double bond and ends at the carbon.